Sorry, we got cut off a little bit at the end of that last one. I start talking about math and I just keep talking. I'm trying to do these at least a little bit quickly, but I do want to give you guys some insight. You haven't been, having the nice in-class experience, so I'm trying to be as thorough as I can, but trying to go fairly quickly. I don't necessarily want this to be, 2 hours, but I do want to talk about all the pieces. If there are particular problems you're looking for, fast forwarding through might be helpful for you. And particularly number 10, you won't be asked to graph this much stuff and do this much stuff on your actual exam. This is, again, 2 to 3 times longer than your exam will be. But I want to make sure you're practicing graphing. So I don't think we'll graph each of them. I just want to make sure that when you're graphing, you have some good habits. Make sure you draw yourself a nice large graph anytime you're asked to draw a graph. Graphs really are visual tools. They don't work if they're tiny. So we really want them to tend to be big. Make sure you label your axes. They're usually X and Y, but again, one of the reasons we label it, sometimes this is T for time and R for revenue, or sometimes it's W for water and B for buoyancy. So make sure you get in the habit of labeling those. You also want something that gives a sense of scale. So I don't know, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, with some at least enough labeling to make sure your audience knows what they're looking at. And the scale on a single axis should be consistent. I haven't drawn it all that consistent, but it should be fairly consistent. But this could be, 1, 2, 3, 4, so that could be 10, and then 1, 2, 3, 4, that could be 20. 1, 2, 3, 4, that could be negative 10. 1, 2, 3, 4, that could be negative 20. So they don't have to match each other, but they have to match themselves. If this is 1 unit on this side, it should be 1 unit on the other. If this is 10/4, 5 halves on this side, it should be 5 halves on that side. So each axis should be consistent with itself, not necessarily with each other. So be sure you're getting in good graphing habits. As you go into 112 and or calculus, those good graphing habits will pay off a lot. So you're asked to graph those. The big ones that I think I'll look at the graph of, hopefully graphing the lines is okay. But for example, if you're asked to graph number 9 here, the nice thing is 8 and 9 are really the same graph because they're the same equation. But we've got our vertex here at 3 halves 0. So we should be able to plot. 3 halves is 1/2, so 3 halves 0, we got a point. We know the y-intercept is 9, so it has a nice y-intercept of 9 there. We know it's a parabola, so it's symmetric. So if this distance is 3 halves, then if you go out another 3 halves, you're going to hit the parabola again. So if that's 3 halves to 1.5, this is going to happen at exactly 3. So you get a 0.310 there. Make sure that logic makes sense for you. If this distance is 1.5, the fact that this is symmetrical means this distance has to be 1.5. So as I said, we should label some key points here. So just make sure you're labeling 3 or 4 of the interesting points when you make your graph. If you have x-intercepts and y-intercepts, make sure you graph those and label those. You're just trying to make a nice, neat, polite, well-labeled graph. If you have any questions on some of the graphs of the other ones, plot them in your calculator and look at the graph. Make sure it's consistent with what you're graphing. So this certainly isn't all of 10, but the other parts of 10 really are just those lines. For example, for 7, we could graph really all of them. So it's going through 7 with a slope of 3. So you could, graph that line. And you could just, do them on separate graphs, though. You want to get used to doing nice, neat, tidy ones. And again, I'm not going to ask you to graph, 3 or 4 things on top of each other as one question in the middle of the test. But you should expect to see at least some graphing questions, especially with the parallels and perpendiculars. So I just want to make sure you're going to be happy with that. So number 11. 5 equals 3x squared minus 4x, and we're asked to solve. Hey, we're finally asked to solve something. So it's a quadratic. Generally, when we want to solve quadratics or any higher order polynomial, anything higher than linear usually, setting it equal to 0 is usually one of our first steps. So I'm going to subtract that 5 from both sides and move things around so I can get it all at equal to 0. Now generally the first thing you want to do with any quadratic is see if it's factorable. If you can factor it, it's going to be faster, it's generally going to be more accurate, and you're generally going to be happier. So if your factoring skills are a little rusty, make sure you're practicing those. There's some information on my website that can help you practice your factoring. So we want to be sure to practice or to check if it's factorable first. But 3 times 5 is, or negative 5 is negative 15. Nothing multiplies to negative 15 and adds to negative 4. So it's not going to be factorable. So if it's not factorable, we could use completing the square, but we use completing the square to build the quadratic formula. So generally, factor if possible, quadratic formula if not. So we have an A, a B, and a C. I like to start by building that discriminant, B squared minus 4 times A times C. That'll tell me how many solutions I have. If I don't care about the imaginary ones and I know they're all complex, I can just stop doing the problem and say, hey, there's no x-intercepts. But even if we do have more to do, it really doesn't waste any time for us. So what, 16 plus 12 times 5 is what, 60? So the discriminant is 76. So we'll have 2 real solutions to this. And now we can go find them. People often complain that they wasted all this time on something they have to do anyway. But the nice thing is you can actually simplify the quadratic formula to negative b plus or minus the square root of the discriminant over 2 times a, because that's what we found here, was the part under the radical. So this just turns into negative 4 plus or minus the square root of 76 over 2 times 6, and all we have to do is simplify that. I think it's handy. If you don't like it, don't do it. But I think it's handy. Still, be able to use the discriminant either way. So 4 plus or minus the square root of 76 over, why did I put a 6 there? Because I did the multiplication. Sorry. That should be 2 times a, so that's 2 times 3, which becomes 6. Apologize for that. Now, we do want to simplify 76 if we can. I don't think there's anything in 76 that's handy. Nothing that occurs to me. But simplify it if you can. And of course, we can't divide those. We can't simplify the 4 and the 6 because there's nothing multiplying in here. So those are our answers. If we were asked to graph that, some people say, how am I going to graph radicals? Square root of 76. The square root of 64 is 8. The square root of 81 is 9. So this is somewhere between 8 and 9. 4 plus 8 and change is 12 and change. 12 and change divided by 6 is 2 and change. So this number is 2 and change. Do the same thing for the minus, and you can get good senses of where to graph these things. A lot of people look at square roots and say, I have no idea. But this is 8 and some decimal-y stuff. So you can get good approximations about where things are, enough to graph them anyway fairly quickly. So, number 11. Do make sure you're practicing your solving and all your different kinds of techniques for solving, especially that factoring. People start ignoring that factoring once they have quadratic formulas, and you don't want to do that. 12, complex adding, multiplication, and dividing. We'll really use that a lot more later. I'm not so worried about it, but I want to make sure you're remembering that you've been introduced at some point into complex numbers. The big thing is things like 4 plus 2i. If you want to add that complex number to 3 minus 5i, it's really just like collecting like terms. 4 plus 3 is 7. 2i plus a negative 5i is negative 3i, and you have your nice result. It couldn't be nicer. So just make sure you look over those things. Multiplying is almost the same. If you're multiplying, 5 minus 4i, you get the same things as you normally would. You FOIL it like you would if they were x's. So what, 10 plus 15i minus 8i. The trick is here you get negative 12i squared. the 10 plus, what, 15 minus 8 is 7i, minus 12 times, the key is that that I squared, that's the square of the square root of negative 1, that I squared becomes negative 1. So 10 plus 7i plus 12, or 22 plus 7i. So the fact that that simplifies back down to something that is complex, that doesn't have an I squared in it, is really important. That gives us the closure of the operation of multiplication. Closure in the algebraic closed set use of the word. The tougher one is usually things like division. And we generally don't like division of anything. But the key is we have to make that denominator real. We can't divide these into the 2 and the 3 separately because there's too many terms in the way. So we really like that denominator to just be a good, solid, real number. And as you may recall, we can always multiply complex numbers by their conjugates. We change the plus to a minus, or a minus to a plus, and it will turn into a real number. It sets up essentially a difference of squares. So that denominator becomes 25 minus I squared when you FOIL it out. You will get a 5i and a minus 5i, but 5i minus 5i will turn into a 0. We have to FOIL out this whole numerator here. This is a separate problem from those. So we still will get, 10 plus 15i minus 2i minus 3i squared. So we'll still have to simplify all that, but you'll see this denominator in a moment. Let's see, that turns into, 13i. That turns into a negative 1, so it turns that into a plus. So 13 plus 13i, that's cute. And we get 25 minus the I squared is a negative 1. So 13 plus 13i over 26. We do want to separate those because we do want it to be in the a plus bi form. But also, notice, some of those simplify. Actually, they both do. That's 1/2 plus 1/2 I. So it's got fractions in it, but it is now a single complex number because it has an a plus bi, where this was 2 complex numbers being divided, 2 plus 3i over 5 plus I. So that really does accomplish our complex division. So mostly I just want to remind you that you've seen some of those things. We'll play more with complex numbers in Chapter 4. I wouldn't focus on them too much for this exam, but I just kind of wanted to take the opportunity to remind you. Let's see, story problems. Okay, we're all getting almost done here. 13. Let's see, a company's revenue is the amount of money that's coming in before you deal with costs, is approximated by this function. And when we talk about regression coming up here pretty quick, you'll find out where some equations like this come from. But we're asked, we're told that the R is in thousands of dollars and the X is the current price of the product in dollars. How much should the company charge to maximize revenue? Well, this is a function. If we do that distribution, you'll see very quickly that this is a quadratic because of the x squared. And with the negative coefficient of the x squared, this is a parabola that opens downward. So it really does have a maximum. So we can find that maximum. And we could find that maximum by building this into the vertex form if we really wanted to. But again, you have that tool. The x value of the vertex is negative b over 2 times a. And we have the b and the a here. So the b, be careful, the b is the linear term, the coefficient of the linear term, what's on the x. So that's negative 2.335 over 2 times negative 0.005. So the x value of the vertex is whatever that result is. Let's see, negative 2.335 over negative 0.01. The negatives are going to go away. Move that decimal twice. It's going to move that decimal twice. So 233.5. So the x value of the vertex is 233.5. Now, in context of the problem, we're told that this x is the price in dollars. So the price in dollars that will maximize the revenue is $233.50. All word problems should be answered in a sentence. Be sure to do that. So the price to maximize revenue should be set at $233.50 for whatever this product is. Now that's only the first part. The problem then does go to ask you, what will the maximum revenue actually be? Well, the revenue R is the Y value, the output. So we'd have to then find the value R at 233.5 to find the Y value of the vertex. But you can find that by, plug the X value into either of these, really. Plug the 233.5 in for those X's and calculate your revenue, and just make sure your sentence that answers it, again, all word problems answered in sentences, just make sure your sentence is in thousands of dollars, because you're told, again, that the R is in thousands of dollars. So I'll calculate that out real quick when I'm done here and add it to this, so you can check it by looking at the version online. But you'll have some other sentence that says the maximum revenue, and you really should be spelling these out, is whatever that number ends up being, thousands. Can't spell today. Of dollars. So, nice, quick little problem. Okay, 14 and 15. I'm sorry, but 14 and 15 are going to have to be on the last video. I was hoping not to have to make 4 of them, but I think we're going to have to. So I'll see you there in just a minute.